Hi students, now we are going to look at Pn Junction Diode, right? So it's an interesting concept, just listen carefully. So when I take a semiconductor crystal, consider this is a semiconductor crystal, whether it can be germanium or silicon. If one side of this crystal is doped with some trivalent atoms or acceptor impurity atoms, then it becomes P region. If the other side of that same germanium or silicon crystal is doped with a donor impurity atom, that is donor impurity atoms or pentavalent atoms, then that side, that region becomes an N side or N end. So this becomes P end, this becomes N end, and becomes a Pn diode forming a junction at the midpoint. So since a junction is formed at the middle, this is called as Pn Junction Diode. Okay. Now, here in this P type or in this P side or in this P region, this negative sign encircled, this encircled negative sign indicates the immobile negative ions. I'll say why. And here in the P region, holes are the majority charge carriers. And in the N region, these are the immobile positive ions. I'll say why. And here in this N region, the electrons are the majority charge carriers. Okay, once if this Pn junction is formed, then the electrons or the majority charge carriers from the N side crosses into the P side via or through the junction, and the holes, the majority charge carriers of this P region will cross the junction and enters into the N side. Whenever these electrons enter here into P region and holes enter into the N region, a recombination of holes and electrons will take place. Here recombination means whenever the holes, that is positively charged particles and negatively charged particles, if they combine, positive and negative, they get cancelled. That is what we call as the recombination of holes and electrons. Whenever they recombine, then nearer to the junction, these holes and electrons will recombine and disappear, leaving only the immobile negative ions on the left hand side and immobile positive ions on the right hand side. So this region where we have the immobile negative and positive ions is called depletion region. Since the right hand side has positive immobile positive ions, this has higher potential. So the N side, the potential of the N side is higher than the potential of the P side, because here in the left hand side it has negative immobile ions, right? Due to which an electric field is set up in this depletion region. And the junction, or there is a barrier created whenever we find a difference in potential between these two regions, that is on the right hand side and on the left hand side of the region nearer to the junction. Okay, so this barrier prevents the further movement of electrons from N side into P side and the further movement of holes from P side into N side. So this barrier, which prevents the electrons and holes crossing the junction, is called as the potential barrier. And the distance between this point and this point is called as the width of the barrier. See, this potential barrier, for silicon, the potential barrier is 0.7 volt. For germanium, the potential barrier is 0.3 volt. So, this is all about your Pn junction diode. Thank you.